that we're looking at before we start sketching. So from looking at this, you should be able to recognize that this is a polynomial function. It's not a rational function because there's no fraction. It's not an exponential function because the variable x is not up in the exponent. And it's definitely not a log function because there's no log here. You don't see log anywhere. So because it's a polynomial, we would have to refer to the steps for a polynomial. So it's a polynomial function. And can anybody tell me what the first step for sketching a polynomial function is?
Group-like terms.
What do you mean, group-like term?
Like to where you'll, I don't remember what the exact term is, but the opposite of factoring it. How right now it's factored, basically just put it all back together.
Multiply it all out.
Yeah.
Is that what you're saying? Yeah. So we're gonna do something similar to that. We're trying to figure out what the end behavior is. Okay, so we want to know what's happening on the left and right hand sides of this polynomial. That was, does it go up or down on the left or right? And to do this, we have to look at the leading coefficient and the degree of the polynomial. So this is where I said you look at each of the factors and you say, what is that really acting like? And we said, like x is really like a 1 times x. And then this, if we ignore the -4, is really like another 1 times x, because there's a 1 in front of that x. And this last one, what is this last one really acting like? What is it behaving like?
1x squared.
1x squared, good. And that's because we have a little squared there. So if we were to multiply those together, 1 times 1 times 1, and then x times x times x squared, we would get 1x to the 4th. And that's where we can look to see its leading coefficient is 1, and the degree of the polynomial is 4. So we have the degree of 4, which is an even number. And then we have a leading coefficient of 1, which is positive. And that's where we refer to that table. And I will give you the table on the final. It'll be like the last page of the test. You'll have that little table will be provided. All right. So looking off that table, which should be in your notes, you should be able to determine that the left side goes up and the right side goes up. And in the middle, we don't know. Okay, so that comes from the table. Any questions on that part? All right, third step are the x-intercepts with the multiplicities. So this is where we're going to figure out where the polynomial touches the x-axis and whether or not we bounce or cross at each one of those. So to do that, all we have to do is take each of the factors up here. I'll do this in a different color. We take each of these factors, doing this in blue here, and we set each one of them equal to 0. So I'm going to set x to 0. I'm going to set x minus 4 to 0. And the x plus 8, even though it's being squared, I only have to set the factor equal to 0 one time. So we solve each of these for x. The first one is just 0. The second one, we add 4 to both sides. We get x is 4. And then we subtract 8 on both sides here, and we get x is negative 8. So we have 3 x-intercepts. Now we have to determine whether or not we bounce or we cross at these x-intercepts. So here's where we go back up to the original function, and we look at the powers on each of these factors. So let's start with this x is 0. X is 0 actually came from this factor, and the power on that factor is a 1. 1 is an odd number, and so what happens anytime we have an odd power?
Cross.
Cross. So we're going to cross here. Then we go to the 4, we say, okay, that came from that factor, and again, the power on that factor is 1, which is odd again. So we should cross there. And then the -8 came from this factor, but this one was squared. That's an even number, and anytime you have an even, you'll bounce. And that should be it. We should have everything we need now to draw the polynomial, or to sketch it. So I'll do it over here to the side. So I always like to start off with my X and Y axes. And now let's go ahead and draw this thing. I'm going to put my X-intercepts first. So I know I hit at 0, at 4, and over here at -8. I also know that both the left and the right-hand sides go up. So I know that, I'm going to move this 4 out of here. I know my left side goes up. I know that my right side goes up. And now I just need to connect the dots together, paying attention to whether or not I bounce or cross. So as I draw from this left side, I start drawing down to come towards that -8. I'm going to bounce off because, well, it says here bounce. So I'm going to bounce off. And then now I've got to come back and connect to the 0. But when I do that, I need to cross through. And then I've got to turn and go back towards the 4 and cross through again. And then connect that right side that goes up. And there it is. That's what we're looking for. So what do y'all think of that type of problem?
Yeah, it seems pretty easy.
Okay, good. Yeah, I mean, like once you kind of catch on to what you're doing, it should be pretty straightforward. I feel like historically students have done pretty well on these problems, all right, which is good. That bodes well for you for the final. All right, let's move on to number 2. Number 2, exactly like number 1, it's just more complicated. There's some more things happening here that we have to pay attention to. So the first step is to recognize it's a polynomial function. Okay, so we know it's a poly. The second step is to find the end behavior. So let's talk about what each of these things are doing. You have to be a little careful here. All right, so look at this first guy right here. What is that one really kind of acting like? What's the number in front of that?
So -1.
-1. Okay, so we have a -1, and then it's x squared, so that's just x squared. And then what about this one? What is this one acting like?
1x.
1x
Square.
1x squared, yeah. So the squared means I'm going to want to put a squared up here on that x. Get rid of that. Okay. And then this last one, okay, there was a 1 there, there's a 1 here. How about this one? What's this one acting like?
1x cubed.
1x cubed. Okay, so one thing to be a little bit careful with here, all right? See this -1 in the front? It is not getting squared. Because if -1 was being squared, -1 times -1 would be +1. That's not what we have going on here. It is separated. Okay, so there's a separation between that -1 and the x squared. So when I'm sitting here trying to figure out what the leading coefficient is and what the degree is, when I multiply all those together, -1 x squared times 1 x squared times 1 x cubed, when I put those numbers together, -1 times 1 times 1, I have a -1. And then when I put the x's together, x squared times x squared times x cubed, I add up those numbers, 2 plus 2 plus 3, that's x to the 7th power. So the degree of this polynomial is 7, which is odd. And the leading coefficient is -1, which is negative. And if we look at the table, would y'all like me to put the table up here one time, or?
Yes.
Yeah, I can do it real quick here. So I'm trying to remember how I did this. I don't remember if I put degree across the top. It doesn't matter how you do it. Let's do degree up here. So the degree is either even or odd. And then the leading coefficient is either positive or the leading coefficient is negative. I think this is the way I did it before.
It was
So
swap.
I'm sorry?
You
They were on the other sides.
Was it opposite? Okay, let's be consistent then. All right, sorry. It doesn't matter how you do it, but I want to be consistent with what I did before. Okay, so degree is over here. We had the degree being even or the degree being odd, and then the leading coefficient over here being positive or negative. So if you have a degree that's even and a positive leading coefficient, it goes up and up. And then if the leading coefficient is negative, it goes down and down. And then if you have an odd degree with positive leading coefficient, it goes down and up. And then it's opposite if it has a negative leading coefficient. So if we look at this as options A, B, C, and D, what do we have here? Do we have A, B, C, or D here? So we have an odd degree, right? Which means we're going to be either C or D. But then we have a negative leading coefficient, which means we have to be one of those. So what we're looking at is where they overlap, which would be that one. So that means our left side goes up, right side goes down. Is that okay for everyone?
Yes.
Okay. All right, so we know what the end behavior is. Now we move on to get the x-intercepts and multiplicities. So to get my x-intercepts, we set each factor to 0. So I set x squared to 0. I set x plus 3 equal to 0. And I set x minus 6 equal to 0. Now I didn't bring that negative that was in front of the x squared down. I didn't bring it only because even if I put a negative here, the first thing I'm going to do is, well, I could divide by -1, but also I just think to myself, what number squared is 0? There's only one number that you can multiply times itself to get 0, and that's 0 itself. It doesn't matter if there's a negative out there. Is that all right?
Yeah.
Okay. So x is 0. X is -3, subtracting 3 on both sides. X is 6, adding 6 to both sides. And now I'm going to go get my multiplicities. So what about this 0? The 0 came from here, and the power there is 2. 2 is even. Even means bounce. -3 came from here. The power on that factor is 2. Even. Even means bounce. The 6 came from here. The power there is 3. That's odd. Odd means cross. So I'm going to have 2 bounces and 1 cross on this one. And now I draw. Oh. Okay, x-intercepts at 0. -3. And +6. Left side goes up. Right side goes down. And be careful here because this is not necessarily going to be the order that you go here is not just like left to right. You have to look at this. The first x-intercept we have is -3. We got to do this bounce first. So I'm going to go here and I'm going to bounce off. And then I've got to go to 0. And at 0, I bounce again. So I bounce off like that. And then when I get to 6, I'm going to cross. And then it should just connect. If you do it right, everything should connect together. That's it. We good? Shall I move on to 3? All right, so 3, again, this is a polynomial function, but it's different because this one is not factored. And I told you, when we were covering this, that, when you look at polynomials, they're either going to be factored or they're not. And there's pros and cons to both, as we're about to see. So the good thing about it being not factored is that it's very easy to find the degree and leading coefficient. The degree here is just the highest power of x that you see, which should be the 4 right there. And then the leading coefficient is just the number in front, which is 1. So we have an even and a positive. And if we go back and look at the table from the previous problem, even degree, positive leading coefficient, it's got to be A. So we've got left side up, right side up, middle we don't know. So that doesn't require a whole lot of work. This is the part that's going to suck, the x-intercepts. Because it's not factored, you cannot just set each of these things equal to 0. You cannot do that because there's not multiplication between each of them. So what we have to do is somehow turn this thing from this expression into things that are being multiplied, which means factor. So we need to set this thing equal to 0 and factor. And this is where we go back to the steps for factoring. And the first step for factoring anything is greatest common factor. And all of these terms have an x squared in them. So I'm going to pull an x squared out. If I pull x squared out of each term, this is what I should be left with. And then the part that's inside right there, that's 3 terms. And so we can try that little AC method thing. That's where we look at the number in the front and the number in the back and multiply those two together. You can also, yeah, I mean, I think this is the most efficient way to do it. 1 times -12, that gives you -12. And then you look at the number in front of the x here, which is a 1. And you have to come up with 2 numbers that multiply to be -12 and add up to be 1. Can anybody think of those 2 numbers? Multiply to be -12, add up to be 1.
Positive 4 and -3.
4 and -3. Good. Positive 4, -3. And so what we're going to need to do is take this expression. I'm going to do it over here on the side. I'm going to just do a quick little grouping on this. So this is where we put x squared here and we rewrite this middle term as plus 4x minus 3x and then minus 12. So all we've done is use this right here to replace that x right there. And now we can do the grouping where we slash it and then we pull a little greatest common factor out of the first 2, which is just x. And out of the second 2, we can pull a -3, and that should leave us with an x plus 4. So I'm moving a little fast through that step because we've done that already. That was on previous tests. It might take you a little longer during the test to do that.
Can I ask a quick question?
Sure, absolutely. Y'all stop me. If y'all have any questions, just stop me. Okay, go ahead.
For the 4 and the -3,
Yes.
how do we get, like, in the order, how do we know that the 4 goes first?
Good
before
question.
the -3?
It actually doesn't matter which order you do it in. It'll work both ways. So had you done it this way, okay, let's say you had done it that way, all right? So instead of saying 4 times -3, or 4 and then -3, you switched it around, right? -3 and 4. Then if you wrote it like this and you slashed it and did your grouping, you'd pull an x and get x minus 3 here. Then you'd pull a 4 and get an x minus 3 here. And then the next step would be x minus 3, that's the common factor, and then the 2 things in front, x plus 4. But down here, these two things are exactly the same. Do you see that? It doesn't matter what order they're in because it's multiplication. So x minus 3, right, that quantity times x plus 4 is the same as x plus 4 times x minus 3. Does that answer your question?
Yes, thank you.
Okay, good. Yeah, it's a good question. It doesn't matter the order, you'll get the same result. So you don't have to worry about that, messing you up or messing things up. Okay, so now what I do is I come back here, I've got x squared, and then those 3 terms become x plus 4, and then x minus 3, and then equals 0. So now it's factored. So now this looks more like the previous problems. So we set each of the factors equal to 0. And we get 0, we get -4, and we get +3. So we've got our 3 x-intercepts, and now it's just bounce or cross. And when we look at bounce or cross, we're not going to be going back up to the original problem. We're going to be looking at the factored version. So we're going to be looking at this version right here and looking at the powers here. So we go 0 came from here, and the power there is 2. So we should bounce. I'm just going to put a B. This -4 came from here. The power on that factor is 1, so we should cross. And then this 3 came from this factor. The power on that factor is a 1, so we should also cross. Here we go. So 0 here, -4, and 3. Next step is always just look at your left and right behavior. So left side goes up, right side goes up. And now when I start drawing this, when I get to -4, I need to cross through, okay? And then when I get to 0, I need to bounce. So I'm gonna bounce, and then when I get to 3, I need to cross. So just for the sake of showing you, that's the correct answer, but for the sake of showing you, what if you had started this problem, or what if you had gotten to this step right here? What if this is where you were and you had said left side up, right side down, and then you started to try and do this, and you say, okay, I'm going to cross through, I'm going to bounce, and then I'm going to cross through 3. What if that happened during the test? What would you be thinking?
The end behavior was wrong.
So it could be that the end behavior is wrong, which means you messed something up with the end behavior. Or it could actually be that your factoring might be off. But this should be an indication that something is wrong, okay? Because you're not allowed to come back and go and connect it, because now you've created an x-intercept that doesn't exist. And so that, I'm just trying to point out that if during the exam, you get to a point like this where things don't look right, you're going to have to just go back to the beginning and just go through everything, make sure you didn't make any mistakes. In this particular case, I just had the end behavior in the wrong place. Okay. So there will be indicators that something's wrong. And if everything goes and connects together smoothly and looks like, oh, look, I wound up with this nice picture, that most likely means everything is right. Okay. Because if you mess one thing up, most likely your picture's not going to go together nicely. Okay, so we've done 3 polynomials. Now we're on to number 4. I have a 4th polynomial, which again is not factored. So let's work through this. So it's a polynomial. All right. The degree of this polynomial is 3. Highest power of x I see. That's odd. The leading coefficient is a 1. That's positive. And so we should expect the left side to go down, the right side to go up using the table. That part's pretty, hopefully, straightforward. Now I need x-intercept. So I've got to set this thing equal to 0 and try and factor. So first step of factoring is GCF. Do I have a greatest common factor here? I don't. Right? There's nothing that comes out of all of them. Why don't I do this? Why don't I give you, I don't know, I give you like 5-6 minutes to see if you can take this and factor it, and then try and set up, get your multiplicities. I'm just going to step away for a second, get a drink, but I want you to work through it. And when I come back, I'll work it out also underneath. But I want you to sit there with pencil and paper right now and see how far you can go with this without me. Okay, I'm going to be working this out here well. Okay, there's all the work. Does anybody have any questions on that? I'm going to highlight an important part of this problem. That part right there, you have to recognize the difference of squares there. X squared minus 16 breaks down to be x plus 4, x minus 4. How did that go for you all? Were there any questions? We're happy?
If the number is even, right?
For what? I'm sorry, I didn't catch the first part of that.
If the number is even, you cross, right?
What number?
Oh, for like the x's.
Okay, so I think you're asking me, how did I determine this cross, cross, cross?
Yeah.
Okay, it has nothing to do with the numbers. Nothing at all. It has to do with the powers on the factors. So it has to do with, see if I can get this to erase here. It has to do with when you got this 2 from this factor right here. You have to look at the power on that factor. It's a 1. Because it's odd, you cross. Same with this negative 4. The power here is a 1, so you cross. This one, the power here is a 1, so you cross. So I'm glad you asked that, because that's one of the most common mistakes that I see, is that students will look at these numbers and say, oh, somehow the number tells you whether or not you bounce or cross. It's not. The number tells you where you're actually on the x-axis, but it has nothing to do with the bouncing and crossing. It's all about this power on the factor, which is what we call the multiplicity of the factor. Okay? If you go back and look at the 3 examples I did before, I always went back and looked at that power on that factor. Is that clear?
Yeah, thanks.
Okay.
Question, where'd you get the x squared minus 16 from?
Okay, so when I did GCF, I looked at the first 2 terms here and I said, what do they have in common? So I pulled x squared out, right? They both have an x squared. And that left me with the x minus 2. And then I looked at the second 2 terms and I pulled out a negative 16 so that I would also have an x minus 2. So I pulled out minus 16. So if this x minus 2 and this x minus 2 match, then what we do is we write that down, and then we always put the 2 things that were in front inside parentheses. And that step right there, we call that grouping. Okay, this was factoring by grouping. And that was the technique that we always use when we do grouping. Once I did,
Steve, I'm sorry, I mean to cut you off. No, I missed the x squared in the front. That's
oh,
what
okay. Did you just pull an x?
Yeah.
Okay, okay, yeah.
Thank you.
No problem. Okay, anything else before I move on to the next problems? Okay, so it's been, it's been about, what, 40 minutes? What's going on here? Okay, we've been at this for about 40 minutes. We've worked through the first 4 problems, right? So, depending on you and how long it takes you, I would expect that the first few problems here will take you just under an hour. Some of you will probably blow right through them, but as far as time on the test, we have 3 hours for the test. If basically, well, not quite 3. We have from 11 to 1:40, which is almost 3 hours. So first 4 problems out of the way. Let's take a look at the next few. Number 5. Okay, so now we've shifted gears. We're no longer talking about polynomial functions. We're talking about rational functions. And the reason that we know these are rational functions are because we have fractions, right? We've got this ratio of functions. So first thing we always want to do with a rational function is make sure it's rational, okay? It's a rational function. Check. So now we move on and we go through the steps. What is the first step or second step for rational functions? Let me see if I can go back and find this in the notes.
Set the numerator equal to 0.
Here we go. Here's where they were. Good. Make sure it's a rational function. So what I would expect on the test is for me to, I'm not going to give you like all the steps on how to do this. What I'm going to do is I'm going to tell you, find the x-intercept, find the vertical asymptotes, find the horizontal asymptotes. So I'll give you those steps. I'll give you what you need to do, but you need to know that to find the x-intercepts, you set the numerator equal to 0. You need to know that to find the vertical asymptotes, you have to set the denominator equal to 0. And then you have to know what these 3 cases are. All right, so I'll prompt you as to what you need to do, but you'll need to know how to execute the steps. So when we're here, we're going to, I would tell you on the test, find the x-intercepts. All right, so now you would have to say, okay, I know to find the x-intercepts, all I have to do is set the numerator or the top to 0. So you set that equal to 0. This is a linear equation. You should recognize that as a linear equation, which means you add 12 to both sides. What we're trying to do is isolate x, divide both sides by 3, and you get x is 4. So this is an x-intercept on the graph. That's a point on the x-axis. The next step, I would tell you, is to find the vertical asymptotes. And to do that, you would have to know, okay, just set the denominator equal to 0. Now, this is a quadratic equation. You could use the quadratic formula, but I think it's much easier to just do a GCF. Pull a GCF out. And as soon as you pull a GCF, you can just set each of those equal to 0, each factor equal to 0. And you get 2 answers, 0 and +8. These are not dots on your x-axis. These are those vertical barriers that you're going to draw. Okay. 4th step is to find the horizontal asymptote. So with the horizontal asymptote, here's where you have to look at the different possibilities. And so what you do is you look at the degree of the numerator. The numerator has a degree of 1. And the denominator has a degree of 2. So if we go back and look at these, you know what? I may just give you all this part. What do y'all think of this? What if I give you on this test, I'll give you everything in yellow here. So the stuff in blue, you have to know. So in other words, I will tell you to find the horizontal asymptotes. I will tell you in the three cases, if the numerator is smaller than the denominator, then it's the x-axis. I'll tell you that if the degree is the same, it's the leading coefficients. But I'm not going to tell you anything that's in blue. What do y'all think of that? Does that sound fair for the test? I'll give you all that with, you know, where I'm going to give you the table for the polynomials for the left and right hand behavior. I'll include this right here as it's typed out, but I'm just going to remove everything that's in blue. All right. So on ours right now, in the problem we're working on, we have this first case right here. That the degree of the numerator, remember ours was 1 on top and 2 on the bottom, the degree of the numerator is smaller than the denominator. So the x-axis is our horizontal asymptote. So this is actually that first one, that first case. So it's the x-axis. All right, step 5 is to plot everything. That means put everything down on our graph. So starting out with the x-intercept. We have an x-intercept at 4. That is a dot on the graph. Then we have these vertical asymptotes, these vertical barriers. They happen at 8 and they happen at 0. Now the one at 8 is easy to draw. I just draw a dotted line up and down. And the one at 0 is harder to draw. So I think I told y'all, I know I told y'all, to draw these little dashes like kind of sideways. It's just easier to see it. So those are our two verticals. And then we have a horizontal asymptote, which should be the x-axis. And remember with the horizontal, you always draw it at the end. Do not draw it all the way through. And what you see right there is what I want on the test. Okay, if you do that right there, I will actually give you full credit for the problem. All right. However, everyone loves bonus points. There's going to be very few opportunities for bonus on this test. Here's one of the places. If you now go do test points, where you go and figure out like what's happening here, maybe pick a test point like 2, maybe pick a test point like 6. Maybe something out here like 10, something over here like -2. If you take those test points, plug them into the function, and determine what's going on here, that means, if you do a test point, and then, oh, I should do it in blue, and then figure out that this graph is doing something like this. So in other words, if you could do all these test points and complete the graph, I will give you bonus points for that. All right? But in an effort to save us a little bit of time right now, I'm going to just skip to the next problem. We'll get through all those, and then maybe we can come back and revisit that part later. Okay, let's look at number 6, another rational function. Okay, it's rational. It's going to have x-intercepts. So I set the top to 0. There's a couple options on how to do this. Does someone want to tell me how to go about this one?
GCF.
Okay, what is a GCF that you see here? 2. Okay, so you could pull a 2 out. If you did that, you'd be left with x squared minus 9. Okay, can we do anything with that?
X plus 3 and x minus.
Yeah, good. So there we've got a difference of squares. So you'd have to recognize that as a difference of squares. That x squared plus 9, or sorry, x squared minus 9 breaks down to be x. I don't know why I put 2 minuses. Take that back. I mean, sorry, 2 pluses. X plus 3 times x minus 3. Okay, good. Now you set each of these equal to 0. So you set 2 equal to 0, set x plus 3 equal to 0, set x minus 3 equal to 0. Now, the first one can never be true. 2 is never 0, so you just ignore that completely. The second one is -3. The third one is 3. So you have 2 x-intercepts. These are going to be dots on the graph. Third step, I'll do up here, is our vertical asymptote, or we might have more than one. And we're going to get that by setting the denominator equal to 0. And that is a quadratic. You could use a quadratic formula, or you could go play that game again where you take the 1 here and the -6 and you multiply those, you get -6. Then you take the number in front right here, which is +5, and you come up with 2 numbers and do your grouping thing. So I'm going to save us some time because, again, this is something I want you to be able to do on your own anyway. This should turn out to be x plus 6 times x minus 1 equals 0. So I'm skipping the work for that. Set each one of those to 0. You should get -6 and you should get +1. So we have 2 vertical dotted lines. The fourth step is the horizontal asymptotes, or asymptote. There's only one. If there is one, there's only one. So we look at the degrees. We have 2 and we have 2, right? So what happens when we have the same degree? So I'm going to go back to that thing here. What happens if the degrees are the same? According to this, if the degrees are the same, then the leading coefficient of the numerator divided by the leading coefficient of the denominator is going to be the horizontal asymptote. So this one's a little tricky. You've got to go back here. You've got to identify the leading coefficient of the numerator, which is 2, and the leading coefficient of the denominator, which is a 1, even though it's not written. And then you make a fraction out of those. So 2 over 1 equals 2. That is our horizontal asymptote. So that's where our horizontal dotted line is that we're going to draw only at the edges. Any questions on that step? Because I'm ready to put this all on a graph. Starting with my x-intercepts. These are points on the graph. 3, I have a point. -3, I have a point. Okay, now I put my vertical asymptotes. I'm going to do this in different colors so it's easier for you to see. I have a vertical asymptote at -6, dotted line. I have a vertical asymptote at +1, so dotted line. A horizontal asymptote of 2. Now remember, horizontal means like flat, so that means I've got to go up 1, here's 2, and I am not drawing a dotted line all the way across, right? I'm not going to do this. I'm only going to draw it at the edges. So about 2 units high, about 2 units high over here. And that's what I'm looking for on the test. And again, if you want bonus points, you can go plug in some test points into our function, maybe something like 4. You need something in here like 2, something in here maybe like -1, something in here like -4, something out here like -10. And then once you have all those dots put in there, you should be able to draw the graph. But again, that's bonus, all right?
I do have a question for number 4. I got lost on how you got that again.
Okay, so going back up here, here's the original function. for horizontal asymptotes, you're always comparing the degrees. So the degree of the numerator is 2, right? The highest power of x.
Yeah.
The degree of the denominator is also 2. Those two numbers are the same, right? If you compare them, 2 and 2, they're the same. And the step says that if, so I'm looking at this piece right here, if the degrees are the same, that should say are. I don't know why it says and. If degrees are the same, then the leading coefficient, this is telling you what will happen. If the degrees are the same, the leading coefficient of the numerator, okay, so what's the leading coefficient of the numerator? That's this number right here, the number in front. You take that number and you divide that by the leading coefficient of the denominator, which is the number right here. So that's why I came over here and I put 2 over 1. It was the 2 that's from up here in blue, and then divide that by the 1 here from the denominator, and 2 divided by 1 is just 2, and that's going to tell me where my horizontal line is. Does that make sense?
Yeah.
Okay. You only do that though. You're only going to be looking at the leading coefficients if the degrees are the same. In the previous problem, the degrees weren't the same, so we did something else, and it turned out to be the x-axis. Okay, let's look at the last rational function. Okay, it's rational. Second step, x-intercepts. So I'm going to set the top to 0. That should be pretty straightforward. The only number that you can square and get 0 is 0. So that was pretty clean. Step 3, the vertical asymptote. So you set the denominator equal to 0. That's also pretty clean. Just move the 5 over, subtract it. So you have 1 vertical asymptote. And then the horizontal asymptote, here's again where we're going to compare the degrees. So the degree of the numerator is 2. The degree of the denominator is what?
1.
What's the power on that x? Yeah, it's a 1, okay? So would you agree that the degree of the numerator and denominator are not the same, right? There's a 2 and a 1. So which one's bigger? The numerator. So if you go back to the steps, we're looking at this last one. If the degree of the numerator is bigger than the degree of the denominator, then we have no horizontal asymptotes. So that's telling us that's the third case. We have no horizontal asymptote. That means that there is going to be no dotted line that I draw at the ends. So this is going to be actually really easy for me to draw this part because I have an x-intercept at 0, so I have a point right there. I have a vertical asymptote at -5. And that is it. That's all I can draw. I don't have any other information. Okay, what do y'all think? That's it. Those are the 3 rational functions that I've given you as for the review. We'll move on to number 8. All right, sketching. Sketching what? Well, that's not a polynomial. It's not a rational function. That's an exponential function, right? Because our variable x is up in the exponent. And I told y'all, this was from last time, the way to do this, everyone's going to do it the same way. We're going to put x here. We're going to put the function 1.75 to the x. And this is what your homework was about. -3, -2, -1, 0, 1, 2, 3. Why do you use those numbers? Why are you going to be plugging in those numbers right there? Because that's what I told you to do. All right. I wanted everyone to use the same numbers. So this is where you're going to get on your calculator, and you're going to make sure that you can do 1.75 raised to the -3. So I'm doing 1.75 raised to the -3. And on my calculator, I get 0.187-ish. Then I'm going to do 1.75 raised to -2. and I get 0.33. Then 1.75 raised to -1. I get 0.57. And then anything raised to the 0 is 1. And 1.75 raised to the 1 is 1.75. 1.75 squared is 3.06, or you could say 3.1. 1.75 cubed is 5.36. So everyone should have that same table. Now what we do is we go graph it. So we're going to go and draw our exponential function. This should be an example of exponential growth. I should expect to see something like this. And the reason I know that is because this number in here is bigger than 1. But we want to be a little more accurate. So I know that to the right, I'm going to go 1, 2, 3. To the left, I'm going to go -1, -2, -3, because those are the numbers we chose to plug in. And then I'm going to choose to go up here and start at 6 here. Here's 3. And the reason I chose 6 right here is because the biggest number that comes out here is 5.36. So I want to make sure that I can get this on my graph. So I went up to 6, which is a little bigger than 5.36. So now I just start putting dots in. So I'm going to look at this first one. This is like the point, the order pair 3, 5.36. So that means I go to the right 3, I go 5.36 up. So we're just going to kind of ballpark it. There it is. This next point is like the point 2, 3.06. So I go the right 2 and I go up a little bit more than 3. And then at 1, I'm at 1.75. So I'm about right here. At 0, I'm at 1. At -1, I'm at 0.57. And these just get smaller. It's hard to draw these. And then out the left-hand side, I should expect a horizontal asymptote, because with exponential growth, that's what happens. The right side goes up and the left side starts to drop towards the x-axis. That's it. Yes?
For the exam, are you going to want us to put the coordinates on the side like you did?
You don't need to, no. The only reason I wrote them today is because when I'm about to do the log problem, and with the log, I'm just going to come back and say, remember we flipped these over. So you don't need to on the test. The table itself is good enough. The next problem is pretty much the same exact thing. It's just you have a different, have a different base, 1/3. And so because that number 1/3 is smaller than 1, we should expect to see exponential decay here, not growth. So I should expect my graph to go like this and then have horizontal asymptote over here like that. That's what we should expect. But let's verify that by making our table. So here's x, here's 1/3 to the x. I'm gonna go -3, -2, -1, 0, 1, 2, 3. And I get my calculator out. So this might be a little bit hard to do. I recommend that you make sure that you can get answers similar to what I'm getting here. I'm getting here 27. And then you should get 9. Then you should get 3. You should get 1. You should get 0.33. 0.11. 0.037, something like that. So this time when I draw my graph, I have 1, 2, 3, and -1, -2, -3. This time my scale up here, I'm going to go, I think, up to 30, because the highest number I see here is 27. So I'm going to go to 30 there. And that means that that's like 15. I don't know, we can count by 5, 10, 15, 20, 25, 30. But be careful here because this first point is -3, 27. That means to the left 3, up 27. That puts us about right there. And then the next point is the point -2, 9, which is like -2, 9 is about right there. And then -1, 3 is about right there. -1, or sorry, 0, 1 is there. And then they just get smaller. Oh, gee. Like that. Put a little horizontal asymptote, little arrow over here, and that's good. I think I told you all last time that I'm really, I want your picture to look pretty good, but I'm really going to be focusing a lot of my attention on that table. Just making sure you can plug in everything correctly on your calculator. And then, you know, of course, I would have to take off points if you accidentally had it the other way around. Like that would be wrong. Any questions there?
Do you want us to, so like on the first one, it was like 1.75 to the third equals whatever. Do you want us to do that? Or can we just do like what you did in the second one, just put the numbers?
What do you mean just put the numbers?
Like you just put 27, 9, 3, 1.33. The other one you actually showed like 1.75 raised to the
Oh,
third.
yeah, no, you don't need to actually show me. You just give me the answer, that's fine. I was just doing that to make sure that everyone understood what I was doing on my calculator. Just for that first, you're talking, I think what you're referring to is right here. I wrote that down.
Mm-hmm.
You don't need to write that. I just want to make sure everyone knew what I was doing on my calculator is 1.75 raised to the -3.
Okay, cool.
Okay. Okay, so now what I want us to do is to sketch this function, which is a log function, but notice very conveniently that the base of this log function is 1.75. So the steps to do this are to actually figure out what 1.75 to the x is, and then switch the coordinates, which we already did, right? We did this problem. So what we're gonna do is go back to this problem right here, 1.75 to the x. We're gonna take all these answers and we're gonna change the x and y coordinates. In other words, like this one here is now gonna become 5.36. That's our new x coordinate, and the y coordinate's 3. And then we take this one. Now the x coordinate is 3.06 and the y coordinate is 2. And we do that for all of these. So once we do those, then we go graph them. So I think what I'm gonna do is I'm gonna do it on this same page, so it'll be easier to see it. So I'm gonna draw my graph. What's kind of interesting here is if you think about it, we should have 1, 2, 3 going this way now. And then this direction, I would want to be able to go out 6, because when we flip everything around, everything's reversed. So it's like that whole graph is reversed. So I can go 6 here, I can go 3 here, so on and so forth. So if I go to put this point down right here, 5.36, I move to the right 5.36, and I move up to 3. So it's going to be a point about, let me see, 4, 5. There we go. So somewhere around there. The next point, 3.06. So I go a little past 3 and I go up 2. And then this point right here, when I flip that around, that's going to be 1.751. So I go to the right 1.75, I go up 1. This point flipped around is 1, 0. So that means go to the right 1, but then don't go anywhere. Just stay on the x-axis. And then I keep doing that for these remaining ones. 0.57, -1. So I just move to the right 0.57 and down 1. And then 0.33 down 2. And what you wind up getting is like a vertical asymptote. that make sense to everyone?
That's whenever there's the log, right?
That's when there's a log. Yeah.
Okay.
So notice I gave you the same base here, log 1.75. So I gave that to you. You already made the table for that. So you don't have to, like, you know, if I had made this base like the number 2 instead, you'd have to start completely from scratch. Go here, go 2 to the x, make your table, and then switch everything. But I'm not gonna do that on the test. I'm gonna ask you for the log of the same function that you did before to save you time. So you can see that on number 11, right? This is log, look at the base, 1/3. Well, we did that problem. It was this one. This was it right here, 1/3 to the x. So what we're gonna do is take all these points and we're gonna flip them over in graph. So when I go to do this, I don't think I'm going to work through this whole thing. I'll just give you a general idea. We're going to go 1, 2, 3. We're going to go -1, -2, -3. And I'm going to go out to the right 30, 15. And so let me just take this first point. I'll just plot one point here. That's going to become the point 27, -3. That means go to the right 27 and I go down 3. Be careful there. Down 3, that puts me here. And then as I do the other ones, we should get something like this. I'm missing one there. No, that's not right. Sorry. 3 and then down 1, so about right there, and then here. And we have our asymptote goes the other way this time. Whoa. There we go. Oh, good enough. Okay. Number 10, number 11. 12. So 1, 2, 3. We have 4 more to do. Do y'all want to take a break or just grind through this?
Go through it.
Just get through it? Okay.
Need a pee.
I'm sorry, I didn't hear that.
Be right back. I just need to use the restroom.
Okay. All right, so what we're doing right here is we're just gonna solve these equations, and we're gonna be using a couple of properties. But here's the main idea. I told you all last time that when you see a log base A of x and we say that that's equal to something, this means that a raised to that y equals x. And I talked to you about this idea of this like loop, that this a raised to the other side of the equation must equal what's inside there, right? That was the first thing you need to know to solve these equations. The second thing you need to know is the change of base formula that says log base A of x is equal to this thing that's on your calculator, this natural log key. Those are the two things we need in order to solve these equations. So, looking at this first equation, we're trying to solve for x, okay? We have something raised to the x equals 25. So you can see that over here, it looks a lot like this right here. We have something raised to the y equals x. What I said to do was rewrite this using a log. So you have to rewrite this in a way that you're filling in these boxes in a way that gives you back, when you do that little loop thing, it gives you back this expression. So what would go into this first box, this box right here? What would have to go there?
It would be 25.
Okay, so what's in the box? Look at the formula here. What's in the box here? I mean, what's
Oh,
down?
A. So it'd be
A,
4.
right? A is the thing that's being raised. So this will be 4. Okay, 4 is being raised to what power? Look at that equation up here.
X.
X, so X goes here, and then that means that this must be the 25. So this is all about converting this equation into this new equation. Now, once we do this, get all this, let me just write it underneath. Here's where we are. We have log base 4, 25 equals X. Now we go to this formula. This formula says that we can convert the left side of this into the natural log of 25 over the natural log of 4, and that should be equal to X. So this is where I get my calculator out, and I make sure I know where my natural log key is. And I should get, you should get here 2.32 equals X. All right, any questions there? That problem was as straightforward as they come when it comes to solving these types of equations. All you did is converted it to a log and then use the change of base formula. Let's see how the next example gets a little more complicated. It's almost the same problem, except that you have the 4 raised to the X. So you've got that thing that looks like this, A to the Y, but you have this minus 5 there. So we want to get rid of that. We want to just add 5 first. So there's one step we kind of have to do before we continue. Add 5 to both sides, we get 86. Now it does look like this. A to the Y equals X. So it's almost like we've isolated this piece. So once we isolate it, we should just be able to go straight to the log. So let's see, what's the thing being raised here?
4.
The 4, so the base of this log is 4. 4 raised to the X must be
86.
6. Okay, so we've converted it now. And now we use the change of base formula. The left side becomes natural log of 86 over natural log of 4. That's equal to X. And we do this. Calculator, natural log 86 divided by natural log 4. I'm getting 3.21.
Yeah, 3.21.
And don't worry so much about the rounding. Just give me a couple of decimal places. We're good. All right, let's look at 14. So I'm going to highlight the thing that's being raised and then the power. There it is. We need to get that by itself first. Before we can do any of the rewriting and do the log, we have to get that by itself. So the first thing I want to do is get the 6 out of here. So I'll subtract 6 from both sides. So now I have 3 times 4 to the X plus 1 equals, when I take 6 away there, I should get 116. Okay, still cannot do that log thing yet because it's not the 4 raised to the X plus 1 by itself. I need to get rid of this 3. So how can I get rid of that 3?
Are you just multiplying it to the 4?
Okay, so think of, yeah, I'm glad you asked. So think about this. Just look at this expression by itself. When you think about, you know what, let me change it. Let's forget the X plus 1. Let's just put this as squared. If you were asked to figure out what that is, what would you do first? Would you square the 4 or would you do 3 times 4 first?
Square the 4.
Square the 4, because you have to do exponents before you do multiplication, right? So in this case, we are not allowed to multiply that 3 times that 4 because that violates order of operations. We would have to figure out what this is, the whole thing, before we could multiply by the 3. So that means algebraically, it would be illegal for us right now to multiply that 3 times the 4. So the only other option to get rid of that 3 would be to divide it out on both sides. Okay, because then it would go away over here. We'd be left with a 4 to the x plus 1 equals, and on the right side, well, we just got to get on our calculators and do 116 divided by 3. And I'm getting like 38 point, I'm in around here, 0.67. Do y'all see that? So that's why I give you a problem like this. I want to make sure you understand you can't multiply that 3 times 4. Now this part of the problem looks almost like the very first problem we did here. It's just 4 to the x equals a number, right? But we have x plus 1. So let's see how this is going to work out. We've got log. Okay, what is the base? What's the thing that's being raised? 4 again, right? Okay, what is 4 being raised to?
38.67.
Oh, careful, that's what it's going to be equal to, but it's being raised to x plus 1, isn't it?
Mm-hmm.
And then that must equal the 38.67. Now the left side of this, we can use a change of base formula. That's just natural log of 38.67 divided by natural log of 4. And that should be equal to not x, but x plus 1. So now I need to get on my calculator, do natural log of 38.67 and divide that by natural
2.63.
2.63. Okay, so 2.63 equals x plus 1. So we're supposed to solve for x. We're almost there. Just one more step. Subtract 1. So 1.63 equals x.
So since we have to use our calculators for these parts,
Yes.
my calculator actually has a way for me to do log base for 38.67. Do I still need to do the natural log step?
No, you can use your calculator. Yeah, some of them do. Not a lot of them do, though. So if you have that feature, go ahead. Just make sure that during the test you at least write down this. Okay. That's the thing I want to see. If you go from there straight to here, that's okay.
Okay.
All right. Okay, that brings us to the last problem. And the only difference between this problem and the previous problem is that I'm just using a different base. The base here is e. We need to get that e to the 2x minus 5, get that by itself first. And then when we set up our little loop thing, you know, we just have to be careful that the thing being raised is e. And remember, e is just a number, okay? So don't freak out when you see the e. So I'm going to start out here. I'm going to subtract 1 both sides. All right, so when we do that, we got 5 times e to the 2x minus 5 equals 30. Again, we cannot multiply the 5 times the e, so we have to divide the 5 through. The 5's cancel here. We get e to the 2x minus 5 equals 6. And now at this point, we can do the log. So log, the thing that's being raised is e. We're raising it to the 2x minus 5, and that's equaling 6. So the left side becomes natural log of 6 over natural log of what? What is that? Natural log of e. Okay, so I gave you this example because I wanted you to be able to do this on your calculator. The natural log of 6 you should have no problem with. I'm curious to see how many of you are going to be able to get natural log of e on your calculator typed in properly? So let me tell you what the answer is, and then you make sure you can get this answer. 1.79. The left-hand side of that should be 1.79. If you're not getting it, then we can talk about why and how to type it in properly. But let me finish off the problem first. I'm trying to solve for x, so I need to now add 5 to both sides. So now I get 6.79 equals 2x, and my final step would then be to divide by 2. So 6.79 divided by 2, you should get 3.395 equals x. All right. What do you think? It's 12:25, so it took us roughly an hour and a half or so to get through that. Are there any questions?
How do you put E into your?
Yeah, the E.
Well, what kind of calculator are you using? I need to know. Every calculator is different, so I can't just tell you, oh, just do this.
I think I figured it out.
You got it? I mean, if you're getting, if you're winding up with that, you know, 1.79, if you're getting that answer right there from this right here, then you're doing it right.
When you're putting it in the calculator, isn't it just like you do the ln 6 at the numerator and then the ln e, and then it asks you for like a number at the top, like if it's being square rooted, it's just 1, right? Because
it's just 1. Yeah. So some calculators are going to, when you type in the E on the calculator, it might do E with a little box here, and it wants you to fill that in. Just put 1 there.
Okay.
Yep.
Okay, I got 1.79.
Okay, anything else? Okay, I want to make an official kind of announcement here. I'm going to type it out. That way nobody can say I didn't say it. For the final, okay. I will need to see your entire workspace. Okay, so I'm running into issues, all right? So I'm running into some academic integrity issues where, you know, there are students who are working, they're doing everything that I've asked, but there are other students who are not. So when I say that I want to see your workplace, what I want you to work on between now and Wednesday is making sure that your camera is picking up, like you can see how you can see my whole workspace here. Like I want to be able to see everything. I don't want just this like that. Okay. I want to be able to see what's in front of you and inside of you. So I want that camera to be backed up pretty far from you. And I don't even care if I can see what you're writing. I just want to be able to see what's around you. All right. Because what's happening is we're having students that are, you know, doing stuff here, but then there's other stuff that I can't see, and it's just not fair to everyone. So I want all your workspace on camera. All right. I know that's going to be a little difficult because some of you are looking at the test on your computer. If that's the case, then I'm just going to ask you to write all the questions down before the test starts, and then you can just move your camera away. I'll give you
But
time.
how can I show you my entire workspace if I'm taking the test on my laptop?
You're just going to move your laptop far away. You're just going to have to move your laptop far enough away from you that I can see your workspace.
Alrighty.
But I'm saying if you are looking at your laptop to get the questions, then the very beginning of the test, you either need to print the test out or just write all the problems down. And then once you've done that, then you can start the test. Does that make sense?
Is it possible for you to, well, I don't know if you could do that, like send the test so we can write it all down. So like on the day of, we're not trying to rush to write every question down. Or can you send it? Yeah, I know it's probably.
Send you the test early? I can't do that. No.
Okay.
I can send you the test at the beginning of the test time, and then give everyone, 15 minutes to write the problems down or 10 minutes to write the problems down. I can do that. But
yeah, that works. I was about to say like 5 minutes before the test, we could just write it all down or something. That would work out.
Yeah. Well, I won't do it before.
What if we use it to where we have our test on the screen, but our camera is able to show you what's on our screen? So you can see that all we're looking at is the test.
Not everybody has that ability, though.
Okay.
So some people have a camera that's built into their screen, so they can't, they can't get a camera far enough away. That's why I've said, I think the most ideal camera to use during a test is the camera off your phone. Because then you can move your phone far away. You can plug it into a charger so it doesn't die, and then you just, so just get the Zoom app on your phone and do it that way. But we'll see how it goes. I just expect that I'm able to see everyone's workspace. And it's always just a few students that cause the issue where I have to do this, but I really want to make sure we're being fair on this final. And the fact that I've given you a review and I've worked through all these problems, it wouldn't be fair to have some students sitting there with all of that information where I couldn't see that they were using it. So let's just see how it goes. Anything else?
And for like the, you said you're going to give us, for the rational, you're going to give us step 4 for like the horizontal asymptote. Are we going to have to write that down too?
No. Well,
so like, if we're using our computer for the exam, we're writing down the.
Yeah, you know what? Why don't I do this? I will send you everything that I'm going to give you, okay, that you can use on the test. Why don't I send that to y'all tomorrow? I'll send it either today or tomorrow. And then you can write all that down and have that ready to go.
Okay.
That sound fair?
Yeah.
Okay.
And then another thing, during the test, I use because I use the phone for my camera off of Zoom, and I use another phone to look at the questions you're asking. Is that okay?
That's okay, as long as it's there in front of you, and yeah, that's fine.
Okay.
All right. Well, I don't really have anything else for you all. You can sit here and talk about the weather if you want.
I had another question I'd noticed on Canvas. Whenever you go to the grades to like see what you need to make what grade for the final of the class, it seems as though exam 5 isn't weighted at all. Like no matter what I put in there, the grade doesn't change.
Wait, what?
For the final, whenever I do the test to see different scores and stuff, it's acting as though it doesn't count for any part of our grade.
For the final exam? Let me just go in. I'll just double check it real quick.
Yeah, I noticed that too.
Oh, that's weird. Maybe when I was setting it up, I accidentally put it at 0%.
And I noticed that exam 4 is listed on as the final over on the right, and it for the weight.
Oh, you know what? Yeah, I bet you the grade book came in. Hold on. Give me a moment. I have this. So if you're going to be doing that, it's going to be a little bit tricky. Oh yeah, I see that. Okay, so it's going to be a little bit tricky because, well, I guess you could do it. You could for exam 4 grade, you could put in your highest of your other exams, but you just don't know what the final is going to be, right? So
Will that wind up affecting our like end grade, or is that just how Canvas is just doing something weird?
what do you mean?
Will exam 5 still be weighted like normal, or
No, exam 5 is weighted normally.
okay, so it's just Canvas being weird?
No. This is it's messed up in here. I'm fixing it right now. Hold on.
Okay.
So this should be. Man, I thought I got this all changed. Okay, I'm going to edit this. I'm glad you asked me that, because yeah, you can't really get a accurate idea. Every exam is worth the same amount. Okay, 20%. And this should be.
And you said that our highest score of the exams, including our final exam that we're going to take Wednesday, the highest one is going to be for exam 4, right?
Yes. Okay, so I just updated it now in Canvas, and now it should work. So here's what I would do. I would go in there, and if you're trying to like figure out what grade you need, I would go in there and look at your highest grade that you've had out of exam 1, 2, and 3. Put that in for exam 4, and then start messing around with the final exam grade. If you think you're going to do really well on the final, then you can replace exam 4 with what you think you're going to get on the final. The problem is you don't know for sure, right? But it should be accurate now, Dalton, or whoever was asking about. I think it was Dalton.
Okay.
Anything else?
Do we have to memorize the log a x equals y, raise equal, and then means a y?
Yeah, I would understand. Yes, I'm not going to provide that to you. So you need to be comfortable with that idea.
Okay, thank you.
Yeah. So just know this relationship, and like I said, the way to remember it is that little loop. You know, when I was in school, I was not, and I still am not very good at memorizing things. So, you know, what I did is, you know, once the test like officially started, I would have these things memorized, but then I just write them down as soon as the test started, so that, you know, I just make my own quick little formula sheet out of my mind. The thing you can't do is have a little thing on the side to cheat off of. So if you can just retain it for 5-10 minutes, then you can write it down on your test. That's fine.
Okay, sounds good.
Okay. All right, anything else? If something comes up between now and Wednesday, then feel free to call me or text me, and I'll be happy to clarify things or whatever you need.
And on your syllabus, it's updated for the grading system, right? Like what you're looking for.
Yeah, the syllabus says that we have 5 exams worth 20% each, right?
Yeah.
And that's the grade book now reflects that.
Oh, okay.
Yeah. So if you go and look at your grades, there might be some stuff in there for homework, for quizzes, right? There was a thing in there for quizzes, homework and quizzes. That's all, that's still there, but it's worth 0% now. So. In fact, I'll just delete that so that it doesn't confuse people. Okay. All right. Like I said, if something comes up between now and Wednesday, just get in touch with me. I'm gonna stop the recording here. I'll post this video